Welcome back to my budget app series. In the last few videos, we've been building user interface components in a library, React library with Vite, which we'll later utilize to build our web client. So far, I've been building the components live on video so that you could benefit the most out of any mistakes I make during the process, and you can see architectural decisions as I make them. These few components I'm going to build today, however, which are the table, data grid component, and the dialog component, took a lot of refactoring, architectural changes during the development process, and overall took a lot of time, like 2 weeks of active development. So it wasn't possible to include the live development sessions in a YouTube video format. Because of that, I opted to do the second best thing and make a video after I have built and refactored the components to a state which I consider good enough to start building the web client. They're definitely not finished, they're not tested and all that. I mean, they don't have automated testing suites, etc. And they will definitely be developed further when I start assembling the client views with components. But my goal with the user interface library is to have components that are good enough to start building the web client MVP, and I will develop them further when I use them. So as I mentioned, I will be developing the table component, which will be a purely presentational component. I'll talk about this in a bit. And then a data grid component that takes data in the form of JSON and renders a client-side component that is actually a table underneath presentationally, but has additional features like editing on the spot and others. In addition, I also built a dialog component using the HTML5 dialog element and integrating that with React with state synchronization, and we'll talk about that at the end of the video. So let's jump into the code and I'll talk a little bit more about the architecture and the components we'll be building. Okay, to start, I have the BWUI repository open and I will start the storybook first to look at the components in their finished documented state. So I also categorize them a bit in subcategories, data viz, models, form components, etc. But that's not critical. Today we'll talk about the table, the data grid, and dialog. These are the 3 new components which I've built off camera. And I will start with the table. Let's open Figma also, because we have the reference component design there, which we are implementing. So the table is this thing right here. And it has a couple of different versions because in this form, it has a title plus a couple of columns of values, decimal values for amounts, and then a total row and a button. It also has progress bars here. In another form on the right for transactions, it doesn't have any progress bars. It has different fields which can be for date and a footer which doesn't have totals but a pagination, and still a button for a new item in the respective table. So the decision I've made is to first build the table components. The table component, which is a stateless component, purely presentational, which houses the styles essentially and the variations and its subcomponents to visualize this table. And these styles include the overall table, which is an HTML table underneath, then its header, rows, cells, progress bars, and this footer, including the total row, and a separate component for pagination, which works with the actual table component. The next step is the data grid, which we'll talk about later, that actually renders the table with provided data and adds additional features like editing in place when you click, removal, icons, etc. I'll talk about that later. Now let's focus on the table, which should be simple because table is presentational as I mentioned. So if I go to components, table, we have a couple of files, but it's not really that bad. I will first go to excluding the stories file for the storybook. We have a table file which houses the actual table component. That, as you can see, is just a table HTML element with a class name, which is defined in the SAS file. I'll take a look at that, and then it renders the children. Of course, this is presentational. It's just a simple component with a class name with styles. But I like this a lot, this approach. I've used this approach for all components. I do not style native HTML elements because I can now use the table element everywhere for a different component, and it doesn't have any styles, and I don't have to implement any resets on existing styles for table. And let's look at the styles for this class name. It's nothing very special. I won't pay too much attention to styles. It just has basic resets, paddings, a background color, and radius. We also have a dedicated font size, base font size for the table, which is different from the body. This, of course, all of these can be reset with Tailwind, especially the default font size. And we have a side effect for tfooter, the tfoot element, which can be included as a child to the table, of course. You can also use thead, tbody, but tfoot is special because the table is built so that it expects a footer. I'll talk about that later when we go to rows. As you can see, the table overall has the padding and border radius styles. And if I open the storybook on table, we have a couple of variations. I can actually demonstrate. Let me zoom it in a bit and go to the spacings. So, okay, reset the zoom. Yeah, the table has the actual padding for the item and the border radius. I can also enable backgrounds real quick because yeah, the actual border radius is not very visible like this. So yeah, here's the table padding, and then we go to the actual headers. As I mentioned, the table expects to have a tfooter because you can see that the table itself has a bottom padding, and the last row is expected to not have a padding. The header always has the appropriate padding on top and bottom. The cells do in the header. And the footer is always expected to be in a tfoot element so that it doesn't have a bottom padding. This is to avoid any CSS selectors for last row because of course we can have multiple tbodies, multiple tfooters if we want. That's multiple tbodies and a tfooter, or not have a tfooter. That's expected. And this way, a mandatory tfoot element, table footer, it's more straightforward without complex selectors. You just have to keep this rule and the table will always render properly. And the selectors, CSS selectors, are more simple. Okay, that's pretty much the table container. It's nothing special. Now, of course, it can have children. These children will always be, if I open the story, a thead, tbody, or tfoot. And tfoot is, of course, required. But the others are also required because you have at least one to render a functional table. You can, of course, skip the header if you want, but you would always need a row. So as you can see, the thead, tbody, and tfoot elements in the storybook are the HTML elements. And there's no reason to build React components for them because they are not styled anyhow. They're used for semantics. They're used for, for containers. In tfoot, they're used to indicate the footer, but they don't have specific styles for them. Only side effects apply to the cells beneath them if tfoot is included. That's perfectly fine. Now, the row has a component though. This is essentially the tr element underneath. If I open, it's in a separate file, tsx file, but it's still very simple. It only has a class name, nothing else. And the styles applied to it are very straightforward. We need position relative. Why? Because of the progress bar at the very least. The progress bar for semantics and functional and just for the implementation purposes needs to be somewhere, and I opted to include it in the first table cell. Technically, you can include it in any table cell, to be honest, but it will be always in the first cell. And it makes semantic sense that way. If you're using a screen reader, for example, you get a reading beneath your first progress reading indication beneath the first title, and then you get the values. So it's positioned here, then absolutely positioned to stretch to the row, to the actual table row. And the table row is right here. I can I can show it like this. And the cells inside of it have some additional padding because this is the design basically. So this is the row element, quite straightforward. Now we have a couple of cells. We have a header cell and a normal table cell. They are both, of course, very straightforward. Here I use the COSX node module, which basically just is a simple function that can assemble a couple of class names into a single class name string. And it works on the logic that if this is true, if a segment you pass to this, if an argument you pass to this function is true, it will output its value. So this is valid, and then here I can check if we have a prop font size for text color, text align, I output this modifier, BEM modifier class. And of course, these can be Tailwind utilities. That's fine in theory, but this library, I want this library to work without Tailwind utilities. I want it to work in any environment. So these three modifiers will not hurt anything to just have them. It's all right. I am optimizing, not just optimizing the size of the CSS bundle, but the overall architectural logic and readability and maintainability. Now, yeah, I was talking about header cell. The header cell has a couple of styles. Of course, a different font weight, which is just evident from the design by default. Here we have two sizes. So I have a modifier for large size. Of course, you can just use a utility library to add any font size to this specific cell, but this decreases the variations and it will be the most used option, the actual option I will use. And we have a darker color. These are set to a default light and darker color, and with variables you can set the header cell color and dark color to different values. That's all right. Now, I also have a cell component which is very similar, but has a couple of different properties, and it houses a TD element, while the header cell houses a TH element, which is just semantics for the HTML elements, and we need to have both components. The cell also has padding. It needs to have a border bottom, which is always included regardless of the, let me zoom in. I'll actually zoom in with Storybook. This border is included regardless if we have a progress bar or not, and the progress bar is only the green item on top of the border bottom, which is always 2 pixels. Here's an example without a progress bar, and we'll talk about the progress bar in a bit, but it can also overflow like this, but that's a different state. Now, yeah, we have some vertical align property, but these are very basic properties, nothing special really. In fact, some of the styles between these two can be combined, these two styles specifically. So I might do that to optimize it a bit. It's not too much. But yeah, let's have them in one place. It will be a little bit better. So I did that. And now I can remove the padding and vertical line bottom from here as well. Okay. Now, let's talk about the next component. Let's go to stories. So I talked about the table, which is the root. These are just the children. Then we have rows and header cells, which as you can see have these props, which the header cell had for modifiers, font size, text color, and text align. So basically these are aligned to the right, left, and we have 2 different sizes and colors. Now the cell also has these modifiers, which I use right here, as you can see, and alignment modifiers in rows. So cells in rows, that's basically how it works. And the last component, I think, yeah, the last component is the table progress, which is a little bit interesting because I am using the HTML5 progress element. Let's see how I style that. Again, what's interesting about it, it has a class name, table progress, BEM component, and then if the value, the table progress has, this is the types file, the table types file where the props are defined. I just added them to separate files so that they don't clutter the actual TSX files. So the progress expects a value and a max value, which is optional. And the value is an integer 0 to max, basically. 0 to 100 will be the most frequent case. Yeah, actually, I don't expect there will be any cases above 100. There's just an option. And if that is above 100, so the progress bar overflows, I have a modifier, BEM modifier overflow, which we'll see what it changes, basically the cover. And then we set the progress bar value and max. This value, we output the integer value and percentage, which is hidden for screen readers and other fallback for when the progress element cannot be rendered. So let's look at the styles. Here it is, table progress and table progress overflow. So we set, as I said, position absolute bottom 0 left 0 because it's positioned inside of the row. It has position relative so that it's above the border bottom of 2 pixels. Additionally, I reset the WebKit appearance and other browser appearances because progress is always styled somehow close to operating system natives. And the actual progress bar is 100% width always. The inner progress, that's not the inner progress, that's the entire bar, which can be filled. And the height is 2 pixels because the border is also 2 pixels always. And I don't want that, at least I don't think I want that to grow with REMs. Maybe I'll change that when we see how it scales up. And then with WebKit progress bar and progress bar value, we can style the inner elements. The bar is, of course, the entire bar, and I style that to the color I want. And then the value is the actual loading part. As you can see, it's green. And the overflow modifier, what it does is it sets the color of the bar to the value to red because the width is already auto-calculated. So I don't need to do anything. That's great. Using these native HTML elements is great because accessibility pretty much comes out of the box. You just have not to screw it up too much, which is hard, actually. Yeah. And let's look at the story file again to look for other components. These are basically all of them. Now, as I mentioned, in the footer, we can have a couple of things. This is basically the tfoot. It just contains normal row and cells, but I made sure I can house a button, for example, like this, an icon button of type link. This is one of our button styles right here, just so that I can remind you. These are the buttons and the link buttons are these. And I made sure this works out of the box by modifying a little bit its native the button font size, yeah, to match the base font size. And that thing can be reset with Tailwind, but it just makes sense to have a consistent font size. And here, what else? In the totals, we just render cells basically with font weight bold. That's a property of cell. So the tfoot is not special in any way, except if I measure again, you can see that it doesn't have the bottom padding because the table has it, and that way the table ends consistently. So it's required for that reason. Now the pagination story, let's take a look at that. It has the same tfooter with a button. Let me show it. We have a button in one cell, and in another cell, which has a call span of the rest of the cells, we have this pagination component with 2 buttons. And this pagination component is also presentational and extremely simple. Here it is, a div with a class name. And that div is just a flexbox container with some gap. Now, I expect the pagination will be changed later because this is extremely basic and quite honestly not the best pagination controls because you don't see the current page. The current page at least is very useful to have and actually almost required for anything that has 2 or 3 pages. You also don't see how many pages you have or anything like that. But this is the bare minimum, and I don't want to spend too much time currently on pagination capabilities, as I don't expect them to be utilized that much for transactions. But definitely in the future, I will extend this further. So this component will be more complex, and it's great to have it as a separate component for now. So this is the table so far. As you can see, it's only presentational, styling-wise, stateless component. It doesn't have any functionality. Of course, looking at this design, I need to be able to, for example, edit somehow, because this doesn't really incorporate it, because I wanted to edit in place. When you click on an item, edit properties, right there with an edit box, and then click enter, escape, or to the site and save your changes immediately with optimistic UI basically. And I wanted to have a delete button pop up when you focus a row. And of course, the new transaction will be a dialog. So in addition, the data I receive from the server is JSON for all of these. And I don't want to render tables in my client. So I've built a data grid component. Now a data grid can be quite a few things. The term data grid or grid, it's usually a data visualization component, generally that takes raw data in the form of whatever, JSON, XML. These days, JSON is pretty much standard, and renders a data visualization component with some client-side interactivity. I would define it like this. In most cases, though, that would be a heavily interactive client-side, heavily client-side interactive table with sorting, filtering, pagination on the client, sometimes grouping by columns and other features. Edit in place like I have. For my needs, I would recommend, if you need a complex grid, you can find many options from already made tested options, free ones like AG Grid, for example. It has a React Grid, a free option that includes a lot of things. And you will get a very functional grid like this. You have whatever, everything pretty much. Now, I don't need that kind of functionality. I don't need something so complex. I could still opt to use that. But I also don't want to do too much on the client. So for this application, I can implement a grid in a reasonable amount of time that serves my needs and extend it in the future to include anything additional I need. And I'll have the flexibility of having my own grid. To be honest, this is also very hard to theme if you want a custom theme for it, because it has a lot of features. This is a lot of components, CSS variables. It's not an easy task to theme this, but it's easier than implementing something that complex. No doubt about that. In general, if you have demanding applications with a lot of data, where the data is king and the data needs to be modified on the client with complex filters, sorting, etc., and you don't have the time, better theme something like this. I'm showing you AG. There are grids from Material UI, for example, and other user interface libraries. You can find paid ones that are also great because they have support and stuff. But yeah, as I mentioned, I'll implement something. First of all, this new transaction functionality is not a part of this. It will be a modal dialog, so it's just a button. Stateless, the grid doesn't care about it. Previous and next end pagination will not happen on the client. Now, pagination is an interesting topic, client-side versus server-side. There are pros and cons to both approaches. In general, I would opt to do everything possibly server-side. With pagination, you have that drawback that sometimes server-side only pagination, like I plan to do here, can be slow in terms of user experience, because whenever the user presses next, you have to make an HTTP request of some sort and then wait for the data to render. That can take some time, some delay for the request to happen. And this results in a folder usually. If you have a lot of data though, paginated in many pages, that's perfectly acceptable because you don't need to prefetch all of the data to implement client-side. If you have a lot of rows, client-side pagination becomes non-viable because you have to take all the data in advance, as I mentioned. On the other hand, if you don't ever have a lot of data and pagination is sort of cosmetic, client-side can be good because you make one HTTP request. If the data is a small amount, the user experience will be seamless because you switch pages immediately. And the last option is a hybrid approach, which is the most complex, but it has the fewest drawbacks, where you have server-side pagination, but you prefetch a couple of pages, usually one additional page or three, so that when the user clicks, he gets the perceived experience of client-side pagination, but your smart code in the back fetches the next and previous pages, and he doesn't see really a folder at any point during normal use. That's why I usually need to prefetch like 2 or 3 pages forward so that the HTTP requests can catch up with fast next pressing. So for now, for the MVP, I will go with the simplest route, which is server-side pagination only. the simplest and more architecturally sound route. I'll go with everything on the server, and then if I have user experience issues in terms of loaders that are annoying, I will optimize that and make the code more complex. No need to do it in advance. Okay, so basically because this is all happening on the server or in a modal dialog, this stays static. And the rest in this data grid takes, let me show you the data grid component now. It has a folder and the stories. I'll go to the stories. So this is what you're seeing, and this data is just a single object, which is demo data. And that's pretty cool because this is something similar to what I will get from a database, from the server, HTTP request. And that's how I want it to work. I want to pass this data and render a grid. If I close that, the grid is a single component that gets a couple of props here in args. A data prop, which has any type and it accepts any object, JSON object, and calls, which is a column definition object. Let me show you. Column definition, which defines the actual columns here and what to render in each row. Because keep in mind two things. A row is equivalent to an object in the JSON array, but a row in the data grid does not need to render all properties, might need to add different labels to the header for each property. In fact, it always does. For example, take a look at, let me open the story again. In fact, if I look at the code definitions here, the data actually first. ID field is not rendered at all. Let's say title field is not header is not rendered as title, it's rendered as transactions. So we need to be able to remap these. The number is reformatted to include a unit, for example. So all of these things happen in the column definitions. You map a field to a column in the grid. And here's how it basically works. I'll open the types. You enter the field string, which is the JSON field, a label, which is the custom label of the column. Then you have some properties for text align, font size, font weight. This is basically for the actual cells. Because look, this column title is aligned to the left and it has certain cell properties, while these columns have different properties. All right, so we need to control that on per column basis, and per column basis is good. This I don't think is valid anymore. Yeah, that I removed that for performance reasons, but I do have a header cell renderer. So what is this? A header cell renderer is a custom function to render a custom component in the header right here. And I use it to not pass these props for headers and cells. So for the header cell, I can pass a simple JSX to render a custom thing. While for the cells, I don't allow that because they're more complex. The headers are always static. The cells here, as you can see, have some interactivity, which we'll talk about in a bit. And we have the editable option. That's a Boolean. When enabled, you are able to edit a column with different types. We'll see how I did that. And you can also remove it. That's controlled by the editable flag. We have input type. This is for the edit. Currently, I allow text, number, or date. These are the types of inputs. These are inputs internally, you'll see. And then unit suffix, which is a string that is applied as a suffix to the value, useful in this case for decimal values, which is very much needed for my application. Okay, so I did talk about the column definitions. Let's go back to the data grid. So you define columns, pass the data, then we have a property for which field uses progress. Yeah, that I'll talk about this in a bit. Can you delete rows? An option to the grid. I thought I coupled that with editable cell, but that doesn't make sense, of course, because you delete the whole row. So yeah, that's also a property. And then we have onChange and onDelete methods. And we'll talk a little bit in depth about these, but basically the grid does not delete anything and doesn't change anything when I make changes here. What happens is right now I've set console log, but in a real use case, I will send a request to the server here to change the grid and get the new data and re-render the cell. Now let me go open my DevTools and I'll show you I console log call change events. So here there, I output a change event. Let me zoom in. A change event and I send back row data. The data for the row so that I can take the ID, the properties, and perform an update on the server. That's basically it. Okay, now I also have an on delete. Let's see how that is implemented, because that's the somewhat complex and interesting part. I've tried to simplify it as much, and that's why hopefully it won't sound that complex, to be honest. Okay, so here's the data grid root component. It takes these props I talked about, data, code definitions, and progress element and delete roles. And it renders a table, the presentational table I showed in a bit, this one. Then it renders a table header, which takes the column definitions and branches into two options. As I mentioned, we have this header cell renderer option. If we have that function, we return it. And it's expected to return some JSON, JSX. Like I should use it here. Let me see. Here it is. Header cell renderer. See, I render a custom header cell right here with some props. Font size 0 and text color dark, which is to achieve this different style of the header compared to the normal one. Okay. So in the other cases, let me open the data grid. In the all other cases, if there is no header cell renderer, I render a header cell with some default options for the column, text align, and I render the label or the field. So if I always have a field because the field maps the JSON data. A field is actually here in stories, like the title field, the date field category, that's field, this string. And if we have label, which we do for all of these, for example, date, the field date is mapped to a date with uppercase D, so that it's more less machine, looks less like parsed machine data, more user friendly. So that's why we render label or field right here as a fallback. And that's the header row. We render that with a map. And the body is similar. We map through data. This is the JSON data. We take the row and index and we pass it to this data grid row component. So let's go and inspect that. It's in a separate file. Before that, after the T body, I render props children. This is because, as you can see, we don't have a table footer here. I opted to have the table footer static. Here I have it. So this is the children of my data grid. I have a static table footer because all the contents of it are static. This button will have its own on-click method that opens a model, and the pagination will also have its own logic that's separate from the grid, and the grid doesn't concern itself with pagination at all in this setup because it's server-side, as I mentioned. And let's talk about the role now, as I mentioned. Let's go right here. Yeah, in the body for each row, we render a data grid row that accepts a row, that's the data, the JSON object from the array. We pass the column definitions and a couple of events, and the progress field, on delete rows, and on row change events. Let's see how these are implemented. This is more complex now. As we go deeper into the grid, it gets more complex because we have editing functionality. So here I have collapsed a few things. We have state now. All right, so row data, we take as props and we convert it to a state variable here because we need to change it because we have editing. So we also need to have state, not just passed top down presentationally. And we have this state here because when data changes, we send back the data for the whole row, not just for the cell. Because the cell change event, if it sends just the value of the cell, is not useful. Database updates happen on a per row basis with the ID of a row. So that's the logical place to have the state for a row. And this just renders a single table row here. We have a custom class with CY, CSS class. And then we map for every column definition now, as I mentioned, not every field in the JSON, because of course, column definitions can display less fields than the JSON data includes. As it is, we don't display the ID here. And for each column, we render a data grid cell passing down the row, column, on change, and progress props to it. And here we actually parse the progress value, which works quite simply. We denote one field as the progress field with string, and it's expected to be a floating number. So we parse that to float and multiply it by 100 because it's expected that the progress field will be 0.5, 0.25, and we convert that to 25 so that it can be used as a percentage, and the progress bar component expects 0 to 100 or 0 to max. Okay, and we render the cell. Let's talk about changes now. On cell value change. So here, the data grid cell component, we'll talk about how I've implemented that, but it can change. The change is when I click on it, focus, and do changes. So when this happens, I call this function here, which updates the raw data state with the new value of the cell. And then if we have an on-row change, which we do have usually, it calls that with an event. So I've made this change event type that just passes raw data with the updated row. And we use this prop to pass a notification upwards to the data grid component that the row changed, so that we can have that prop callback right here on change that's connected to this, which basically gives us, let me remove that, it's a mistake, which gives us an event to hook onto and make the update server side. And that's basically how on cell value change. And here, as you can see, after we render all columns, if we have the delete rows prop option, we render an additional column, a table cell rather, in the row with this delete button element, which is just a button, and it calls this delete handler on click. That's this element, which is absolutely positioned. That's why we need this class, special class for the row and the button. And this delete click handler doesn't do much because it's expected to happen server side. So if we have this on delete, we call it with the raw data because we need that. And here is how the event works. We just pass the prop. And here we'll receive when I click it, let me show you, and I open DevTools, I have an on delete event with the raw data, and I can delete the raw server side. Quite simple. All right. This is basically how the row works. And now let's go deeper to the cell, which is the lowest level component. Here we still have some things that are happening. It's not simple at all, for sure. It's actually the most complicated component for the entire grid. So the cell has a couple of state values here. Let me explain them one by one. First of all, we save the cell value as state, and we use the initial value, which is from the props. Basically the row, the field. We take the row value from the field specification. Quite simple. We have the cell value. Now, why the other cached value is needed, I'll explain in a bit. But we need to have a state for the cell value because, again, it changes. So it needs to be stateful. We have a ref to the input. I'll explain that later. Let's first talk about the cell value and how we edit. Here we just render a table cell. Quite straightforward. Nothing special. We pass a few props for font size and font weight from the code definitions. That's not that interesting at all. Everything in a cell is not just plain text, but an input. This input is great because I can have 3 input types. For example, a challenge with this in-place editing is that you need to validate data. For example, here I cannot input text, I can only input numbers, which is necessary. Here I need dates and a date picker also. So I have 3 input types for now. In the future I'll have more, maybe I'll have a select here for category. Text, date, and number. And I can do that easily with an input. These inputs are styled to be invisible, and if a cell is not editable, I pass read only to them. With CSS, data grid cell input, I reset all styles so that they are virtually invisible and add this outline on focus so that you can see that they are editable actually. Now, speaking about that, the type again, as I mentioned, is defined in props call input type, and it can be text, date, or number for now. We have a control input, which is has the cell value as its value, and the on change it sets cell value. And here's how the editing magic happens. I don't change this value on change. Let me open DevTools. If I change, we don't fire. Let me clear DevTools. I don't fire change events for every single change here because that would be inefficient. We're talking about server-side updates. I do this on board. And on board only if the value is different than before you focused and started changing, because only then I want it, which is why I need this cached value state. And on board we have a board handler. Let's see what it does. Basically it checks if cell value is equal to the cached value, and in that case it returns because we don't want anything to happen then. Otherwise it caches a new value, and then if on change prop is defined, it fires an event to tell the subscriber essentially with that prop that the cell changed, which is the row. And then the row notifies the grid, and then the grid notifies the subscriber, which will do the client-side update. It bubbles up. That's how it works on board. Pretty standard actually. It's not that interesting in terms of behavior. All changes that you do here. Now, one thing that this implies is that if I focus this input, blur by default only happens if I click outside. I want it to happen if I click escape and if I click enter also, because this is now kind of a form. So I need to do that. For that, I have a ref of this input right here, input ref, and I do this effect, a key down event listener that checks if the key is escape or enter, and then if the input ref is available, we blur it programmatically. And I clean up this event listener in the effect so that when the component unmounts, it's removed from the document. And the last thing, on focus, let me see. On focus is only for input type date. Yeah. And it shows the picker because this date picker is not shown by default on date elements when you focus them. And I want to show that picker. I use input type date, and this is the default date picker for Chromium, I think I'm using, yeah. On Firefox it will be different, but I force that on focus because it's just good user experience overall. And yeah, this is basically the input, the interesting part. Then we have the suffix. If that is defined for the column, we just render a span. This right here. It's just a span. It has some styles. I won't go in depth. It just has margin left, and it's inline block, I think, or yeah, inline block. That's only rendered if it's available, and then if there's a progress, props progress, I render the progress bar in the first table cell, and it's right here, absolutely positioned beneath that. So this is the magic that the grid does. In terms of usage, as I mentioned, you would just take the data, define the columns like this, and you get these two events to modify data. So overall, you're getting a pretty easy experience in terms of usage. The footer, again, this one is static. So you need to implement that programmatically outside in your view. The pagination will be just two events basically, which send a query to the server, and transactions will be again a modal dialog, which we'll talk about in a bit. So this grid is not that feature rich for now. For example, you cannot sort. We don't have editing capability for category because it's expected to be some kind of select element, maybe select input. But that's not that necessary for now. If you need to change the category of a transaction, you can remove it and create a new one. This is an MVP, so I focus on the most important features, which wouldn't take ages to develop. And that's how the data grid works. Again, I encourage you, if you want to implement such a thing, such a component, think carefully if you want to. It depends on the complexity you expect it to reach. This will never be this complex, ever, for whatever reason. In the very best case, I would extend it with, like, in a very late version, in years time, maybe. It will have the feature to edit in place enums, like category with selects. Maybe I will include a more complex pagination that's not just server-side but hybrid, and potentially some sorting, but that's pretty much where it will go. And these three features I mentioned are not that complex to add to it. But even with the features I've implemented, I probably have a lot of bugs, which I'll find in the automated testing. So if you need a grid with a lot of features out of the box and you don't have a lot of time to develop it, I encourage you to use something ready. Even if you write all of your components from scratch, a grid is a very good thing not to develop and reuse ready. You save a lot of time, a lot of headaches. You can style these grids. They usually have some theming options, which are not easy. I wouldn't say they're easy. As you can see, this has a lot of elements. It's hard to style it. It's not really that flexible usually. But again, if you need a lot of features, it's much easier than to implement them. Let me just open that again because I closed my storybook. Okay, let me switch again to dark mode. And the last component I implemented is the dialog, which I have right here. Let me show you right here. I utilize that a lot, especially for these new buttons, new transaction, new income. This is pretty much what I'll use it for. Maybe some other cases. I've made it very usable. It's not just for forms. It can have any content, essentially. And I use the HTML dialog element because it's native. And yeah, it just makes sense to use it. It has its own layer. It's now available in all browsers, so everything is great. What's not great is that you need to make it work in React and React's state mechanisms, which is not that easy actually. And let me show you how I've done it. First of all, let me do a demo. It works. It has a backdrop. So we have a close button that closes it. This is a form that's validated, and on submit, it's a form type dialog, so it closes the dialog on submission, which is, I guess, expected. And we have a heading. Now, this is a prop. This is enabled if set in the props, and this is the actual children, the button and inputs. Now, here's how that works. Dialog. Again, I have a couple of elements, but that's not that scary actually. Here's the dialog component. And I have a hook. I will explain why. So the dialog itself is not really stateful. I wouldn't call it stateful. It doesn't have state, but it has an effect. And that effect synchronizes the prop I pass. Let's see the props first. This is the dialog props. We have children, of course. Is open is the prop that will tell the dialog if it needs to be open or closed at a certain time. So the dialog itself is not stateless in the meaning that it doesn't control its open state internally. And you want that because you want to open it from the outside. You want to close it from the outside, whatever. It needs to be flexible like this. On key down is just the dialog elements on key down event. And we needed to implement the escape clause for the dialog. On clause is actually, I think, not implemented at all right now, and I might not need it at all. But it's supposed to be an event that fires when the dialog closes. As close button is a boolean to indicate if that button should show up, and title is this. So let's see how these work. Ignore the ref and effect for now. We have an HTML dialog element, and inside of it, we just have contents. This is the header, which includes a title and a button. Oh, I actually need on calls, of course. Sorry. I need on calls. I forgot my architecture. And then we render the children in a div. That's pretty much it. This header has some styles. It's display flex. Let me show you. Zoom in a bit. It's display flex, and it has a margin padding bottom. The dialog has some padding, and the rest is the contents right here. So let's go to the interesting part. Here we have an effect. So the HTML dialog element works like this. You can close it with its API. It has a close method and a show modal method. It has an open attribute. But if you pass that, it doesn't show up as a dialog modal. It doesn't have a backdrop. It doesn't position it centered on the browser. So you need to open it programmatically with this show modal option and close it programmatically. The issue with that is we want it to open and close on a state with a state variable, which is outside of this dialog component and passed as prop. So we need this effect, which changes on the props is open when props is open changes, and this effect basically synchronizes the is open with these two methods, because the dialog element has its own internal state. And that's implemented in the browser, in the HTML element. You can think of it like that. So we synchronize these two states, our isOpen prop and the internal dialog state, using these two methods, show modal and close. Quite simple, just branched with an if statement. And now how we control that, you can just leave it like this and implement the state every time. Like is dialog open is a state variable here. Is open is equal to use state, whatever. On key down, if the key is escape and the dialog is open, close it. And then you can do that every time when you use it. I've made this hook to make this easier. When you use a dialog, just type use dialog as a hook, and you get is open, set is open, and the on key down event handler, which needs to be here because the state value is here. And here's how we use that in the story. We use the hook to get this open, set is open, on key down, and then we pass these to the dialog. And now we can use them in the component because the dialog will always be a part of another view that opens it and stuff like that. And we can use this to implement what we need. And yeah. The form, of course, is separate. I also, look, the contents of this is a form with method dialog. This will just close it on submit. And then we have a dialog form component and dialog footer component. These are very presentational, very basic components that are a div and a footer with a class name, dialog footer and dialog form. And what these do, let me open the CSS file. Dialog form says display flex and direction column with a gap, so that you can just add inputs inside of it and they will automatically be ordered. That's just for usability, just syntactic sugar basically. And it's useful, that's it. I can implement that with Tailwind probably to be uglier. Don't like it. Prefer it to be a component in itself because this will be the most frequent use case of a dialog in my application. And then we have a footer that has its own styles. It always positions elements to the right at flex end. It's a row and it has a padding top. And that's pretty much my dialog as well. So I made these three components. With this, the user interface library, so to say, with the atomic components from here is implemented. Now the next step is to start working on the client. but I will do a few other larger components in this library, which I will not do with Tailwind. So my initial strategy, to remind you, was to create these atomic components as separate React components in a library with BEM conventions and modifiers, and then use Tailwind to compose these into a layout and do slight tweaks to position things and stuff. Now, I do not want to use Tailwind to build the navigation bar, for example. And this main layout, these two things, the nav and this main layout that will be a two-column layout everywhere, needs to be kind of custom. I can do it with Tailwind, honestly. Even though it has this, maybe I can do it with Tailwind. Probably I can, even though it changes quite dramatically on mobile. Yeah, I can do it with Tailwind, but I would prefer this to also be two components, the main layout and the side navigation, because everything could just be neater, cleaner, and stuff like that. I use fewer utilities to be more readable. So that's my strategy. Next video, I'll start working on the client, but I will build the navigation and the main layout in this library in this BWUI library, most likely. And then we will install that in the next, in the BW web client, Next.js application, and we'll start composing the view. So yeah, that's the plan for next time. With this, I'll wrap today's video. If you enjoy the content and the series, don't forget to subscribe to get notified when I release another video. Take care.